Hey guys, what's up and welcome back to the Rocket Hub. My name is Philip and today I'm going to explain you everything SpaceX needs to catch a super heavy booster and the problems I see in their approach. Let's dive into this interesting topic and start right away. SpaceX is advancing almost every basic principle of rocketry to a whole new level with their Starship system. Let it be the revolutionary Raptor engine or the new and futuristic design dominated by the flaps used for the unique aerodynamic descent or even the ambitious reusability efforts. Everything that rockets of the past did and today even still do is taken to the next stage of evolution to create the perfect launch system. On this channel, I've already covered many aspects of its design, like the Raptor engine and the aerodynamic surfaces, on which I dedicated hours of content already. But another important aspect of Starships, or in this case Super Heavy's, design is the system SpaceX is going for in terms of reuse. Instead of landing the booster on a barge like with the Falcon 9, the Super Heavy is going to return to the launch site and is going to be caught right out of the air by a pair of arms mounted on the launch tower. But more on the actual design later. The first thing we might take a look at is the actual reason why SpaceX is going to try to tackle this crazy maneuver. There must be at least one enormous advantage over the Falcon 9 approach that led to the idea of catching the booster out of midair. Well, actually, there are two main reasons. One of them is the sheer time it takes to place a booster that landed on either a separate landing pad or a drone ship back to a launch mount. Starship is planned to be fully and rapidly reusable, able to fly multiple times a day in the not so distant future. And one of the main limiting factors for the length of the time span between launches is the time wasted within picking up the booster, bringing it back to the launch mount, and put it back on it. Although that might just add a few hours to the whole process, a lot of valuable time is lost. By catching a booster out of midair with special arms mounted to the side of the integration and launch tower, and then placing it directly on a launch mount is just beneath it, SpaceX easily shortens the time until the next launch by a few hours. Not that much, but those few hours sum up over the time. And the second, and maybe even more important factor, is weight. Due to the booster being caught out of the air, the engineers at SpaceX were able to remove the landing legs from the design completely, making the booster a little lighter. And with a little, I mean probably a few tons of weight. Making your rocket as light as possible is one of the most important engineering goals in rocketry. Weight requires thrust to push it up, and therefore lots of fuel. And more dry mass in a vehicle means less payload mass, since your rocket is still constrained in mass. So engineers try to lower the weight of the rocket to be able to shoot more payload into space. By cancelling the need for landing legs, the dry mass of Super Heavy is lowered, enabling Starship to launch with even more payload mass on board. There may be some other advantages to the whole booster catching thing, but the named two are probably the most important ones. So, how does the entire booster re-entry and catching mechanism actually work? The actual landing approach already begins just seconds after main engine cutoff or MECO, and therefore stage separation. As soon as the booster gets to a safe distance to the ship, it begins to vent out some hot gases from its main propellant systems. Yes, it actually seems like SpaceX tries to go entirely without RCS thrusters, at least for the Super Heavy. Anyway, The hot gas vented out of the booster begins to slowly turn the booster around so that the engines face in the opposite direction of the booster's movement. Then the center clutch of 9 Raptor engines, which will become 12 to 13 in the future, relights and cancels out the horizontal velocity of the booster and accelerates it in the opposite direction. After completing the so-called boost-back burn, the booster reorientates itself again to enter the atmosphere engines first. At this point, the grid fins on the very top of the booster take over the control of the vehicle and guide it through the air by creating small amounts of lift. If you want to know how exactly that works, you should watch the section about the grid fins on the Falcon 9 in my video about aerodynamic surfaces, since super heavy fins basically function the same way, they're just oriented in a slight different angle. Due to drag and air resistance, the booster eventually slows down from just about 6,000 kilometers an hour to just below the speed of sound, before lighting a still unknown number of its engines again to slow down and hit 0 kilometers per hour right on touchdown, or in this case a bit higher in the air close to the catching mechanism on the launch support tower. But the really complicated system isn't the Super Heavy itself, but rather the launch support tower, or Stage 0, how it is often referred to. It houses a complex mechanism to support the launch and landing of Super Heavy and even later the ship, which is often referred to as Mechazilla, since it truly looks like a movie monster. As of the making of this video, the first Mechazilla is still under construction. Every part of the system I'm talking about and will be talking about is still under development, and we don't know how the finished Mechazilla will look like, so a bit of content in this video is somewhat speculative. That is important to know, since we are going to talk about Mechazilla's design and function now. Mechazilla is basically made up of 4 different systems: the tower itself, the nearby launch mount, the quick disconnect or QD arm, and the catching and stacking arms. The easiest part here is by far the tower, which is just there to house the other systems and to enable access to higher sections of the fully stacked Starship rocket. The tower is about 140 meters tall and is made up of a steel framework. At the bottom of the tower, there's a drawwork used to power the catching arms. Long ropes run through the entire tower up to its top and get redirected to the arms themselves, running back down on the outside of the tower. It is also used to transport fuel, equipment, workers, and maybe even payloads to the top of the vehicle. The second part is already much more complicated than the tower, but is still relatively easy compared to what comes later. The QD arm is located at about 2/3 of the tower's height and is used to transfer fuel, electricity, and data input to Starship, the second stage, and spacecraft on the full stack. QD arms are very common in rocketry and were used on the Saturn V, for instance. But Mechazilla's QD arm is quite a bit different from the common ones, and you should be able to spot differences immediately. Instead of an arm attaching to the side of the rocket, SpaceX engineered a claw to the tip of the arm, grabbing around the vehicle. By doing that, the QD arm has access to both sides of the vehicle and stabilizes the rocket on the pad, but it has to disconnect way prior to launch to avoid collisions. The QD arm only fuels the Starship below, since the connection to the Super Heavy booster is established by the launch mount itself. Speaking of the launch mount, it is fittingly the third system on Mechazilla. Despite looking relatively simple, it has to accomplish way more tasks than you might think. The launch mount is not just there for the vehicle to sit up on, it houses the quick disconnect systems for the booster, takes care of the pad protection and sound suppression at launch, and holds the vehicle down when conducting static fires or other tests. The mount is basically a ring of metal and concrete sitting high in the air upon 6 massive concrete pillars. When ready for liftoff, the Super Heavy's engines are encased by the mount in the center of the ring, and the vehicle is held in place by a set of clamps pressing against the booster's hull. Yes, the entire 5,000-ton vehicle is floating above the ground, being held by just a few little clamps. That may sound ridiculous, but hey, it works. And then there is the actual catching mechanism. It is made up of a sledge running up and down the outside of a tower on rails as well as two long arms, often referred to as the chopsticks. These chopsticks can be moved by massive hydraulic systems by almost 180 degrees to adapt to the movement of the incoming booster. The chopsticks are designed to position themselves in a way so that two of the booster's grid fins touch down on each of the chopsticks. Additionally, the chopsticks are also being used for vehicle assembly and bringing the booster back to the pad, replacing the cranes currently used for those operations, and also they will be able to reduce the stress and nose count of the starship during stacking, because that isn't good for the TPS tiles as we have seen in the past. All in all, Mechazilla is probably the most complex ground support equipment to ever exist. It does many tasks that would otherwise have to be done by the vehicle in an easier and better way, and at the same time it enables the design of the vehicle to become simpler. But as good as it sounds, Mechazilla still has some challenges to overcome that could render catching a super heavy out of midair impossible. Going such a revolutionary approach for vehicle reusability brings not only advantages, but many challenges and problems with it. Catching a booster out of midair is certainly not easy. The most obvious and at the same time most important design challenge to tackle is the landing accuracy of the booster. Other than on the barges, there isn't much space for the booster to land on. It is required to reach a specific point next to a launch pad. There isn't much of an error allowed here, or the booster would be unable to be caught by the tower. And getting the accuracy of the incoming booster down to less than a meter is quite complicated. SpaceX already has about 6 years worth of experience in bringing rocket boosters back down to Earth, but the landing accuracy of a Falcon 9 booster isn't anywhere near what is required for a safe super heavy catching maneuver. Pinpoint accuracy is essential to avoid crashing into the chopsticks or the tower itself. To lower the accuracy requirements of the booster at least a little bit, the chopsticks are going to adjust to the incoming booster in real time. If the booster comes in a bit far to the left, the chopsticks will move to intercept with the booster's flight path. That does indeed give the booster a bit more space to play with, but also brings another challenge along. SpaceX needs the chopsticks to adapt to the booster flawlessly to avoid hitting the booster or moving the arms underneath it, which wouldn't be good. When the booster touches down on the chopsticks, there is not much space left between the arms and the hull of the booster itself. Moving the chopsticks with a precision in a range of centimeters requires not only high accuracy systems for the movement itself, but also a system to locate the booster's exact position. They may even need a way to predict the booster's position depending on the movement speed of the chopsticks, making a successful landing attempt even harder. Both the chopsticks and the booster itself need to work with a really high precision and accuracy to perfectly make the landing maneuver and not crash into each other. But the booster and the chopsticks not only need extreme precision, but also high reliability. A lot of practice is required to perfect design of Mechazilla as well as the vehicles to push the success rate to a level that enables multiple catches a day, especially if SpaceX tries to catch Starship with the Mechazilla as well in the future. In the FAA Draft Environmental Report released in mid-September, there's a requested license of launches of Super Heavy boosters without a Starship on top mentioned. At first, that doesn't make sense at all, but combined with another license for up to 25 suborbital launches per year, the reason for Super Heavy only launches becomes clear. SpaceX is probably going to try and launch Super Heavies to a height of just a few kilometers and then try to catch it with the Mechazilla to practice landings. Loads of attempts are needed to bring reliability up to a level so that the system can truly enter service and get into operation. This chapter is at least somewhat speculative. The suit flaws in Mechazilla's design are just issues I see in its current design and nothing official. There are just some aspects in the system leaving me wondering how SpaceX is going to solve these problems. And that's what we're going to do now. Look for possible failure sources and see how SpaceX might tackle them. The first thing to note here is that although the Mechazilla design has its flaws, most of the possible failure points have already been fixed. I mean, when I can find them, SpaceX's army of engineers should be able to do that as well. And they are getting paid for this. Just saying. One of such possible design flaws has to do with the position of the booster relative to the launch mount. To make sure the booster won't damage the ground support equipment too much in case of a failed lead catching attempt, the booster will be caught right beside the launch mount, not directly above it. Should the two chopsticks be attached at two different points on the sledge running up and down the tower, that poses a problem. The two chopsticks are meant to lift the booster back onto the launch mount after landing. When attached to separate points, the two chopsticks would reach out by a different amount, meaning they aren't the same length relative to the booster's grid fins. In the neutral position, on the other hand, the chopsticks are the same length relative to the grid fins. What does it mean? Right, as soon as the booster touches down, the chopsticks would be locked into position since the position of the grid fins on the chopsticks doesn't allow the two arms to get back into neutral position. Luckily, SpaceX attached both chopsticks on one and the same point, meaning their relative position always stays the same. Although design errors like that are extremely unlikely to still exist in the current design of Mechazilla, many of them aren't something you think about first when looking for flaws in your design. Especially this error shows how deep into the detail such flaws can hide. But apart from such theoretical design flaws, Mechazilla has one big problem caused by the way it is supposed to work, and that is wind. To catch a super heavy booster, and later even starships, extreme precision is needed. That is possible by perfecting the system, but everything only works in good weather conditions. But as soon as there is some wind blowing, catching a super heavy could become very difficult to impossible and even pose a danger to the whole infrastructure. When the booster touches down on chopsticks, the booster's hull and the chopsticks themselves are just separated by a few centimeters. Let the wind kick up by just a few meters per second in that specific moment in time, and you have the booster crash into the chopsticks. And you don't even need a lot of wind to make that happen. Basically, the only solution to avoid wind having blow your booster around while landing is either not try to land in windy conditions, which would conflict the ambitious launch number SpaceX is aiming for, or you find a way to predict the winds that will hit your booster in the future to pre-counteract them. Yep, looking to the future is literally the only way I see to fully avoid the problem caused by high winds. The only thing SpaceX could do isn't escaping the problem entirely, but shortening the time window in that winds would have a serious impact on the outcome of the landing attempt by bringing the arms into final position just seconds from touchdown. By doing that, the winds would have to strike in the perfect moment that lasts maybe about 5 seconds, rendering this possibility unlikely, but not completely impossible. SpaceX's decision to catch their booster right out of the air is pretty ambitious. It may increase the performance of the Starship Super Heavy system and simplify the vehicle by quite a bit, but it brings a whole new level of challenges and problems onto the table. There's a lot of engineering to be done just on the last few seconds of the Super Heavy's flight to make it work. The insane complexity of the ground support equipment and the precision needed to get a booster back to ground safely pose a completely new challenge to overcome that no one has ever tried to tackle before SpaceX. I mean, how should they? They don't even have reusable rockets out there, so. But if someone is known for doing the impossible, it is Elon Musk with his army of top tier engineers. But in the case of Mechazilla and the catching equipment, they may have gone one step too far. The entire system is so complex and ambitious that it might actually not work out in the end. Too much engineering and too little testing could render this system too complex, too dependent on weather conditions and pinpoint precision. But we will see how it turns out. Maybe I'm wrong and Mechazilla is going to perform flawlessly, but for now, I'm a bit skeptical. And that's it for the rundown on the impossible task of catching super heavy boosters right out of the air. Let me know in the comments what you think about this topic, and if you enjoyed the video, which I really hope you did, why not hit the like button and subscribe to the Rocket Channel. If you do so, thank you for that. We see ourselves in the next video, and until then, I'm out. Cheers!